A data set includes data from student evaluations of courses. The summary statistics are n equal to 90, x bar equal to 3.86, s equal to 0.68. Use a 0.05 significance level to test the claim that the population of student course evaluations has a mean equal to 4.00. Assume that a simple random sample has been selected. Identify the null and alternative hypotheses, test statistic, p-value, and state the final conclusion that addresses the original claim. What are the null and alternative hypotheses? We will begin by drawing a hypothesized distribution. The hypothesis is that the mean is equal to 4.00. The question asks us to test the claim that the population has a mean that is equal to 4.00. Well, less than 4.0 or greater than 4.00 is not equal to 4.00. So we would have a two-tailed test. So our hypotheses should be mu equal to 4.00 and mu not equal to 4.00. We could find some critical values for this test. We're not asked to, but we can. And we would do that using Statcrunch. We would begin by pressing question help and then Statcrunch. We can find the critical value by pressing stat, calculators, t. This is a two-tailed test. So alpha is split out into two tails. So that means then that the area that we want shaded in one tail would be half of the significance level. The significance level is 0.05, so it would be 0.025. Since our sample size is 90, the number of degrees of freedom is 89. Click compute, and this less than sign gives us the shaded area to the left. We specified 0.025, and that t value then would be minus 1.987 if we round to 3 decimal places, or minus 1.99 if we round to 2. We could find the opposite of this value, the positive value, by filling in 0.975, which is 1 minus 0.025, in this box. And we get the same value, only the positive, which is to the right of the mean then, shaded to the left. We will also use Statcrunch to find the test statistic and the p-value. Since the population standard deviation is unknown and we are using the sample standard deviation as an estimate, we should click Stat, T-stats. This will be a t-test. This is one sample with summary. We don't have data in a table. We have the measures. The sample mean was 3.86. The sample standard deviation is 0.68, and the sample size is 90. We are to test about a hypothesized mean of 4.00, and we should make sure that the not equals, less than, or greater than matches what is in the alternative hypothesis, which was not equal to, since this is a two-tailed test. Click compute. We find a t-statistic of minus 1.953 if we round to 3 decimal places, or minus 1.95 if we round to 2. We also find a p-value of 0.0539 rounded to 4, or 0.054 if we round to 3. Our critical values were minus 1.99 and positive 1.99. And so using the critical values and test value method for the hypothesis test, we would say if our t-test value is less than minus 1.99, in other words, if it lands in this rejection region, or if our t-test value is bigger than positive 1.99, in other words, if it lands in the upper rejection region, then we should reject the null hypothesis. We found our t-test value to be minus 1.95. That does not land in the rejection region. It lands in the region where we do not reject the null hypothesis. We found the p-value to be 0.054. Remember that if the p-value is less than alpha, we should reject the null hypothesis. But this p-value is not less than alpha. 0.054 is not less than 0.05. So whether we use the test value and critical values or the p-value and alpha, our conclusion should be the same. Our conclusion would be, do not reject the null hypothesis.